First part of this question is we have to decide if this salt is acidic, basic, or neutral. Then again, we go back to its parent base, sodium hydroxide, which is a strong base. And its parent acid is HCOO. Instead of Na, put a H. So it's the first member of the organic acids, and it's a weak base, weak acid, sorry. All carboxylic acids are weak. Therefore, you have tendency to go after the stronger parent, so this is a basic salt. And its pH should be bigger than 7. Then I follow the question, and this time I give you initial concentration for this salt, and I'm saying what is your pH, and I'm also giving you pKa. But before I solve this question, I want to resolve something. In the last tutorial, I said pKa plus pKb is equal to a constant 14, which is pKw. And I want to say where this number comes from, of course, at 25 degrees Celsius. So let me write the equations. The first equation I go after is methanoic acid. It's a weak acid, reacts with water, to a tiny extent has partial dissociation, gives you HCOO minus, plus releases some hydronium. So you agree this is your acid, this is your conjugate base. If we write equilibrium expression for this, we write it K expression subscript A for acid. And its products divided by the only reactant that is concentration changes, not H2O, HCOOH. Now let's see what happens to our salt hydrolysis. I said if you have a salt that has HCOO minus, that is going to break H2O and react with H2O in this fashion. It will give you the acid back, and it will release some OH from H2O in the system. In this case, you should agree this is the base, this is the conjugate acid. If we ask you to write equilibrium expression, you write K subscript B this time. And you put the products in numerator being multiplied by each other divided by the reactant. Now what happens if we multiply Ka times Kb? Let's see what happens to our equations. So I'm going to take Ka multiplied by Kb. The first equation, the ratio is written again in yellow. This is your Ka. Multiplied by the second equation in green. Now some terms are going to be cancelled out. HCOO in this numerator goes away with this. HCOOH in this denominator goes with this one. What you're left with is Ka times Kb is nothing but product of hydronium multiplied by hydroxide, which is Kw, which is 1 times 10 to minus 14. Now, if you take the log of this both sides, you will get pKa. One of the rules for log is when you are multiplying, their logs get added up, plus pKb is equal to pKw. So this is true because the reactions, when you reverse them, they happen to follow this order. Now let's just go back to the second equation and let's just solve for it. So pKa is given. Now we know in this salt, sodium does not react with H2O. There is no hydrolysis, no reaction. But we know the last name, HCOO minus, is going to react. So let's just write that equation. Gives you HCOOH plus hydroxide, pH bigger than 7. Now this is a base dissociating to give you a conjugate acid, so I need Kb. So from pKa, first I'm going to find pKb. pKb plus pKa is 14, so 14 minus 3.75 is my pKb, which happens to be 10.25. How would you find Kb? Just inverse log or 10 raised to negative pKb, 10 to negative 25, and that will give you 5.6 times 10 to minus 11. So we have Kb. Let's just plug it in. We go after ice. I'm going to do ice in one line if you don't mind. It's initial concentration minus x. By now, if you have seen the sequence of videos before, this is friendly. If not, backtrack a couple of slides. X and x are here. Equilibrium dissociation constant is equal to 5.6 times 10 to minus 11, which is equal to products over reactant. We have an assumption to not solving it quadratically. Kb is much smaller than 1, that we can say 0.1, take away a fragment, tiny fragment is equal to 0.1. So x, which is nothing but hydroxide, is simply square root of this times that, which becomes 5.6 times 10 to minus 12. And if you do this, you will get 2.37 times 10 to minus 6. Now if you take a negative log, you will find POH. Make sure you remember that. Many of us make mistake at this stage. POH is negative log of OH. And you will come in the neighborhood of your exponent, which is 5.6. Now pH plus POH is 14, so pH is 14, take away 5.6, which is 8.4. So it's a basic salt, and we just can put the initial concentration and find it. Hopefully you had patience for this video.